All right, guys, today we're going to continue our Unit 6 on circles. We're going to talk about the arc measures. And last week you guys did, on your activity, your circles on the back board, have pictures of the major arc and the minor arc and the semicircle. So we're going to talk about that a little bit today. So what is our I can statement? I can calculate arc measures. So that is just like calculating measures of angles. We can also calculate measures of arcs and circles. So the first one we're talking about is the central angle, an angle whose vertex is on the center of the circle. So as we take a look at this angle, its angle is ABC. And if we look, our measure is 30 degrees. Okay, it's that easy. It is the measure of the angle on the inside of the circle. Okay. Our next one is minor arc. The points on a circle inside the central angle, which is less than 180 degrees. So if you look on this circle, our minor arc goes from point A to point C. And so we write that as AC with a little arch over top of it. That shows that that is an arc, and its degree measure is just 30 degrees. It's the same thing as the central angle. A major arc is the rest of the circle that's not part of the minor arc. So if we look at our circle and we draw it all the way around the other side, this is arc ADC. We use 3 letters to write minor arcs. Now, to figure out the measure of the arc, we know that a whole circle is 360 degrees. We just have to minus off the 30 that's given to us to give us an arc measure of 330 degrees. And then our last one's a semicircle. We know a semicircle is half of a circle. So if we just put some points on there, we can go ABC. Put those on your circle. And then we can name it arc ABC again. And we know that a semicircle is half a circle, and it's always 180 degrees. All right, so here are some examples that we're going to talk about. We want to see whether or not this little tiny arc right here is a major, a minor, or a semicircle. So if you look at it, it's really small. We know that that's going to be a minor arc. Taking a look at the next one, does everybody see how it goes all halfway across the circle? Halfway across the circle is what? Semicircle. And then last but not least, this is a humongous arc. Does everybody see that? It's almost all the way around. So we know that that must be a major arc. Okay, they're super easy. The minor arcs are small, semicircles are half the circle, and major arcs are almost the entire circle. So we have 4 little theorems here in the middle that are pretty self-explanatory, but I'm going to read them to you. It says the arc addition postulate. The measure of an arc formed by 2 adjacent arcs is the sum of the measures of the 2 arcs. That just means you take 2 little arcs together and you get a big arc. The congruent circles theorem, it says 2 circles are congruent if and only if they have the same radius. So circles that have the same radius are congruent. Congruent central angles theorem. In the same circle, 2 minor arcs are congruent if and only if their corresponding central angles are congruent. So again, remember those central angles, those are the ones that are in the center of the circle. And so if those angles are congruent, then you know the minor arcs are also congruent. And last but not least, the similar circles theorem. All circles are similar. Obviously, little circle, big circle, medium-sized circle, they are all similar to each other. All right, let's take a look at this next example. It says, is the arc AB, which is here, congruent to the arc CD? If we look at both circles look to be exactly the same, and then they both have a 46-degree angle. And so if we look at that, absolutely, both of the arcs are going to be equal to each other. So the answer is yes. If you look at the next example, I wrote a 63 in here. Why don't you guys do the same thing? Because what we did is we took 180 and we minus 63 and 54 from it. And that's how we got the 63 degrees in there. So now let's answer the question. It says, is the arc AB and the arc CD equal to each other? That answer is also yes, because they're both 63 degrees. Now let's take a look at this next circle over here on the right-hand side. The first one wants us to find out the arc measure from N to O. So if we look here on our picture, 80 degrees is in the center, so it's obviously 80 degrees. If we look at the next one, it says from O to A. So let me change colors here. The next one we want to find is from O to A. You guys probably have looked at it and know that that one is also 80 degrees. The next one is N to H. So if we look here, here's N, and I go to H. It's in green here. We look on the center, 120 degrees. And then the other one it's asking me to do is from A to N. So that is actually both of these arcs together. I'm doing it in yellow. And so we just have to take 80 plus 80. And when we add that together, we get 160 degrees. All right, now let's take a look at some of these major arcs. The first one says NHA. So I start at N, I trace around to H, and I finish at A. And so then I just need to see which degree measures it goes through. Well, it goes through 120 and it goes through 80. So we add those together. It's a total of 200 degrees. That's for NHA. So let's get rid of that one. And let's talk about the next one. It says HNA. So I start at H, I go all the way to N, and I continue all the way to A. Does everybody see how it takes up most of the circle? It takes up everything but this random 80 degrees right here. So an easy way to do it is just take 360 and minus 80 from it, and we're left with 280 degrees for that one. So I'm going to erase all that. Our next one we're talking about is HON. So I start at H, then I got to go to O and stop at N. So if we look here, it's going through 3 of the 80s. So if I add up 3 of the 80s, I end up with 240 degrees. And then last but not least, our last one says ONA. ONA. So if I start at O, I continue to N, and I end at A. It's another one of those that goes almost all the way around the circle, and it takes up everything but that 80. So it's the same calculation of 360 minus 80, which is 80 degrees. 280 degrees.
Hi guys, Mr. Robertson here. Flip your paper over and let's go over a couple examples here. So look at the first one in the upper left corner of your paper. It says find the measure of each arc. So we want to find G to E. Minor arc G to E is going to be, I'm going to highlight it here, from G to E. And all we're going to have to do is add together our central angles there. So all we're going to do is 26 plus 78. And that's going to give us 104 degrees. Okay, our next one, we're looking for F to G. So I'm going to use red now, and we're going to go from F to G right there, and we can see that it's written in for us. It's just going to be 161 degrees. Our next one is a major arc, GFH. So when we're doing major arcs, we want to make sure that we include all our letters here. I'm going to use blue this time, starting at G, going all the way through F, and then all the way up to H. Looks like it's almost the entire circle, except this little slice right here that's 26. So what we can do is we can just do 360, because the entire circle is 360, minus the 26. And that's going to give us 334 degrees. All right, now let's look at the one right below that. We're going to do the exact same thing. It says find the measure of each arc. What I'd like you guys to do is to try to do this on your own. We're going to click pause and give you a few minutes and let you try to do it. And then we'll hit play again and I'll go through the answers. Okay, so we have arc PTR. So we're going from P to T to R. So we just need to add up each section that we went through. And you can see that you might see that this is actually half of the circle already. And you might know that these are all going to be a semicircle. So it's just going to be 180 degrees. Our next one, which I'll do in blue, is going to be arc TR. So we're going from T right here to R right here. So we're just going to add two numbers. We're going to do 74 plus 42. And you guys should have gotten 116. Our last one, which I'm going to do in red, is arc PT. So I'm just going to go from P to T. Here's P to T. This section right here, we can see is just going to be 64 degrees. All right, our next question says, find the measure of each arc on the pirate's wheel. So what we need to do is kind of break this pirate's wheel into sections to figure this out. So if we go and look at it close, we can number these as 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 sections on that pirate wheel. So all we have to do is take the total degrees in a circle, which is 360 degrees, divide it by 8, and we find that each arc, each one of these little arcs, is going to be 45 degrees. All right, the next problem says is AB, which is right here, arc AB congruent to DC. Well, they both say 46, right? So you might want to say that they would be congruent, but if you notice here, this circle on the left is bigger than the circle on the right. So actually, this one is no, it is not congruent. All right, the next question says, a survey asks people how many minutes they spend brushing their teeth each morning. The circle graph shows the results. Find the measure of arc ABC. So we're going to go from A, which is here, to B, to C. So we need to add up this whole section right here that I'm highlighting in blue. So all we have to do is 120 degrees plus 82 degrees, and our answer is 202 degrees for that one. All right, now let's go back up to the top right section of your notes, and it says, what is the measure of the arc formed by the minute hand when it moves from 2 to 10? So this is very similar to the pirate wheel problem that we just did. We're going to take, first thing we have to do is take 360 and divide it by the sections that are on a clock. So we can see that the clock is broken up into 12 hours. So we can divide it by 12. So we get 360 divided by 12. That would give us 30 degrees. So each one of these little sections that I'm marking off here are going to be 30 degrees. So then it wants us to kind of go back. I'll go in red here. We want to go from 2, which is right here, to 10 o'clock. So we're going to count how many sections that we actually pass through. 1, 2, 3, 4, 5, 6, 7, 8. So we're going to do 30 degrees times 8. That means that we moved 240 degrees for that and the clock on the hands. All right, looking below that, it says, is AB, which is right here, congruent to AB, which is here, congruent to CD? Well, they're marked off for us as 42 degrees, so we can just say yes. All right, our last problem, it says a circle graph shows the percentage of students enrolled in fall sports at the high school. Is it possible to find the measure of each minor arc? If so, find one. If not, explain why it isn't. Well, it is actually possible for us to do this. Let's choose one. Let's choose volleyball. I'm going to highlight volleyball. It says 15% of kids play volleyball. All we have to do to figure out what the actual arc is going to be, so we're going to take 360. We're going to change 15% to a decimal, which means, remember, 15% as a decimal, we'd go over 1 2 times the left, which makes it 0.15. So on our calculator, do 360 times 0.15, and we should get 54. Now that's 54 degrees for volleyball. You could do that with each of the different sports if you wanted to find what the measure of the arcs are. Okay, that's it for notes. You can put it away, and we'll pass out the assignment.